Hello and welcome to EduSathi. Now we'll be covering the topic of quadrilaterals. Quadrilateral. Quadrilateral is a four-sided figure, or there are four lines in a plane of which no three lines are either parallel or collinear. A quadrilateral is a four-sided figure which is formed with four lines in a plane, and the condition is no three lines should be either parallel or collinear. If the lines comes out to be three lines comes out to be parallel or collinear, I'll never be able to get a four-sided closed figure. So it has four sides, four angles and four vertices. Now let's look at a quadrilateral ABCD on our right hand side. This ABCD is a quadrilateral wherein AB, BC, CD and DA are the four sides of the quadrilateral. Angle A, angle B, angle C and angle D are the four vertex angles of the quadrilateral, and AC, that means if I join the opposite vertices I get diagonal. AC and BD are the two diagonals that I have for this quadrilateral. The property of quadrilateral is the sum of all the interior angles of a quadrilateral add up to 360 degree. So angle A plus angle B plus C plus D would add up to 360 degrees. Unlike the case of triangle where the sum of all the angles is 180, in case of a quadrilateral which is a four-sided figure, sum of all the interior angles add up to 360 degrees. In order to find the perimeter of a quadrilateral, I will sum up the lengths of all sides. So AB plus BC plus CD plus AD would give me the perimeter. In order to find out the area of quadrilateral, I generally divide it into two triangles, find out the area of both the triangles, add them to get to the area of a quadrilateral. So if I just look at it, it will be, I am dividing into, with AC as the diagonal, I have divided into two triangles which is ABC and ADC. These are the two triangles that I get. So I find out the area which is half. I will take AC as the base. The height in this case comes out to be H1, and because I'll add them half, again AC as the base and height is H2. So I can take half AC common. I can follow the formula H1 plus H2, which is the third one. Instead of taking half base into height, I can also follow the formula half AB sine C and add them up to get to a final formula which will be half AC, which is the length of the first diagonal, BD, which is the length of the second diagonal, and angle AOB is the angle which is formed between the two diagonals. So it can be half into D1 into D2 into sine of the angle which is formed between the two diagonals. So I can follow this formula. I can find out the area of individual triangles by any method, and I can sum them up to get to the total area of a quadrilateral. Now, there are various types of quadrilaterals. In this presentation, we will be discussing square, we will be discussing about rectangle, followed by parallelogram, trapezium, rhombus and kite. So these are the 6 types of quadrilaterals that we will be discussing today. Let's look at the first one, which is the square. Square. You look at your right hand side, this is what a square looks like. It has 4 sides, 4 vertices. All the sides are equal. All the vertex angles are equal. So that means A, B, C, D would add up to 360 degree. All of them are equal. Each angle turns out to be 90 degree. The two diagonals that you have, AC and BD, both the diagonals are equal in length, and the diagonals bisect each other. Bisect means they divide it into two equal parts. So this part would be equal to this part will be equal to this part. I would say all of these parts would be equal because the diagonals are equal in length, and the length of the diagonal is root 2 times A. So I can just follow the Pythagoras formula. This is A square plus A square, which is 2A square, root of that. So I will get root 2A as the length of the diagonal. The diagonals bisect each other at 90 degrees. So that means the angle which is formed with the diagonals comes out to be 90 degree. The perimeter of a square would be given by 4 times the length of one side, since all the sides are equal in length. Area would be given by a square, or I call it as side square, because all the sides are again length is equal to width that we have. Let's move to the next type of quadrilateral and we'll talk about rectangle. Rectangle. Look at the figure on your right. This is what a rectangles look like. Two sides are parallel and equal in length. So if you look at it, opposite sides that you have, they are parallel and equal in length, whereas the adjacent sides, this is L, this is L, this is B, this is B, whereas the adjacent sides will not be equal. If the adjacent side also become equal in length, it will be the case of a square that I will get. The vertex angles are still 90 degree like the case of square. All the vertex angles that you have are 90 degrees. The two diagonals that you have, they are equal in length, and the length of each diagonal would be given by, again, Pythagoras formula, under root of L square plus B square. This will be AC or BD. Both the diagonals are equal and they bisect each other. So this, all the lengths would be equal, but the diagonals do not bisect each other at 90 degree. This angle is not 90 degree. Whereas in case of square, this angle was turning out to be 90 degree. In order to find out the perimeter, I'll add up all the sides. So it is L plus B plus B. I can take 2 common and devise the formula 2 times L plus B as the perimeter of a rectangle. The area of a rectangle would be given by length into width. If you look at the figure on your right, P is any point inside the triangle. This P is not necessary on the diagonal. So any point P inside the triangle would follow the following equation. What is it? PA square plus PC square is equal to PB square plus PD square. This is the sum of square of its length from all the 4 vertices. So if I talk about P, the sum of the square, so PA square plus PC square is equal to PB square plus PD square. This is a very important property that we have for any point inside a rectangle. A quadrilateral formed by joining the midpoints of intersection of angle bisectors of a parallelogram is rectangle. So we'll talk about parallelogram in a while. If you take parallelogram and you draw angle bisectors, then the quadrilateral which is formed by joining the midpoints of the intersection of such angle bisectors is a rectangle that you will get. Let's look at the third type of quadrilateral, which is parallelogram. Now, the figure on your right shows a parallelogram. Opposite pair of sides are parallel and equal. This side is parallel to this and equal, like same as the case of rectangle, with the difference being the vertex angles are not 90. If I make the vertex angles as 90 degree, it will be the same case as the case of rectangle. So I can say rectangle is a special case of parallelogram where the vertex angles are 90 degree. So opposite sides are parallel and equal. Opposite angles are equal in case of parallelogram. Vertex angles are not 90 but opposite angles are equal. So I can say angle B is equal to angle D, angle A is equal to angle C is what I have in case of parallelogram. The two diagonals that you have are not equal because the vertex angles are not 90 degree. Diagonals are not equal in length but they bisect each other. So this part will be equal to this part which is AO will be equal to OC, but BO will not be equal to OC. Diagonals bisect each other but diagonals are not equal, and diagonals do not bisect at 90 degree. This angle would not be 90 degree. This is only 90 degree in case of square. Sum of two adjacent angles. If I talk about angle A and angle B, sum of the two adjacent angles that you will have would be supplementary or would add up to give you 180 degrees. Other property of parallelogram being the sum of squares of diagonals is equal to the sum of squares of all the four sides. So what I have is AC square plus BD square, which is the square of the diagonals that you have. You have sum of squares of the diagonal is equal to 2 times, because you have two sides which are same, L square plus B square. This is the property that can be applied inside a parallelogram. Each diagonal of a parallelogram divides it into two congruent triangles. If I look at BD as the diagonal, triangle ABD and triangle BDC would be congruent. Very simple reason, because the opposite angles are equal, right? Opposite sides are equal, opposite sides are parallel, so it will be dividing into two triangles which are congruent. Similarly, if I talk about AC as the diagonal, triangle ABC will be congruent to triangle ADC. The two triangles that you will get would become congruent. In order to find out the perimeter, it will be sum of all the sides, L plus B plus B. Combining the similar terms, I'll get 2 times L plus B. Finding out the area of a parallelogram, you can find it out by dividing it into two triangles, finding out the area of one, multiplying it with 2, because the two triangles that you get would be congruent. So I can find out the area of one triangle with any of the formulas, half, base into height. When I multiply it with 2, that half thing will get cancelled out with 2 to give me the formula which is base into height. So I can devise the formula as the base of this, which is AD, into height, which is BL. This can be one formula that I have, which is base into height. The other formula that I can derive is by taking the diagonal as the base. So if I take AC as the base, I can find out the area of 1 and multiply it with 2. So if AC as the base, BH will be the height, so it will be AC into BH. That half thing that you will have will cancel out with the 2 factor to give you only this. Or you can follow the formula half AB sine A, half AB sine C, sine of the angle between them. This half will get cancelled out with 2. So you're left with the formula L into B into sine of the angle which is made between L and B. L and B being the two sides of the parallelogram that we have. A parallelogram that is inscribed in a circle is always a rectangle. So if a circle is given to you and you have to draw a parallelogram inside the circle, that case will only be the case where you have a rectangle. A parallelogram inscribed outside this will be a case which will be the case of rhombus. We'll talk about rhombus after 2-3 minutes. Let's look at the fourth type of quadrilateral, which is trapezium. Trapezium is a figure which looks like this. So you have one pair of opposite sides which are parallel, other pair of opposite sides which are non-parallel. The pair of sides which is parallel is not equal in length. So here the length is A, on the other side which is AD with the length is coming out to be B. One pair of opposite side is parallel. In order to find out the perimeter, I look at the sum of all the sides. So it will be A plus B plus C1 plus C2. The diagonals AC and BD would be given by the formula. I'll just apply Pythagoras theorem and I'll get the result. So if I look at this triangle AC, let me call this point as E. If I look at ACE, AC square will be equal to A plus x1 whole square plus h whole square and square root. Similarly, BD can be obtained by looking at triangle BFD. BD square will be given by A plus x2 will act as a base, h will act as the height. So I'll get up and get the formula for the diagonal. Coming on to the area of trapezium, again a trapezium area can be found out by splitting the trapezium into two triangles, finding out the area of each triangle and adding them up. So if I look at the two triangles that I have, ABD, what is the base that I have? B. So this will be half into base into height is h. The other triangle that I have is BCD. This is the triangle that I have, BCD. Again half, base is A, height is h that I again have. So this is half sum of parallel sides into height, or this is the distance between the parallel sides, is the area that I can get for a trapezium. If the length of non-parallel sides is equal, that means if I give you C1 and C2 as equal, then x1 will also turn out to be equal to x2. This x1 and x2 will turn out to be equal if C1 and C2 are equal. Such a trapezium is known as isosceles trapezium because the two non-parallel side becomes equal in length. The next type of quadrilateral that we'll be discussing would be the case of rhombus. Look at the figure on your right. This is what a rhombus looks like. Like a square? Yes, but with a little bit of difference. That difference being the vertex angles are not 90. Now in case of a rhombus, all the sides are equal, similar to the case of square. Opposite sides are parallel. So opposite sides, not all the sides, opposite sides would be parallel and equal as in the case of square. The difference being vertex angles are not 90, but the vertex angles that you have which are opposite are equal, similar to the case that you have in a parallelogram. So rhombus is a special case of a parallelogram where L is equal to B. Diagonals are not equal in length, similar to the case of parallelogram, but the diagonals bisect each other. The diagonals bisect each other at 90 degrees. So this is what it makes different from parallelogram. In case of parallelogram, the diagonals do not bisect each other at 90, whereas in case of rhombus, the diagonals bisect each other at 90. The simplest case that you can remember is this case. Make a triangle 3, 4, 5, which is a Pythagorean triplet. Similarly, keep this as 3, keep this as 4. You will get 4 triangles with side as 5. This is what a rhombus look like. This diagonal is divided, this diagonal is divided, but the diagonals are not equal in length. They are they are bisecting each other at 90 degrees. Perimeter is 4 times the side. All the sides of a rhombus are equal to each other. To find out the area, I can find out the area of one triangle, multiply it with 4 to get to my answer. So it will be 4 times the area of this triangle. The area of this triangle will be half base. What will be the base? Half of diagonal 1, d1 by 2. And height, the height here again comes out to be half of the diagonal 2. So I can cancel some of the things. I'll get the answer as half into product of diagonals as the area of a rhombus. It can also be base into height. I'll not use the half thing because it's a quadrilateral, it's not a triangle that I have. The last type of quadrilateral that we look at is the case of kite. The figure looks like this. Adjacent sides are equal in length. 2 pair of adjacent or consecutive sides are equal in length. The diagonals are not equal and perpendicular to each other. The diagonals are not equal, but they are perpendicular to each other. It's like a case of rhombus only. In case of rhombus, all the sides are equal. In case of kite, only adjacent side. This pair and this pair is equal. This A and B will not be turning out to be equal. However, the diagonals are perpendicular to each other. The diagonals do not bisect, only the shorter diagonal is bisected by the longer one. So the longer diagonal is not bisected at the point of intersection, but the shorter one is only bisected. So if I look here, only one pair of opposite angles would be equal. This A and C would be equal, but this D and this B will not turn out to be equal. Why? Because if I look at this triangle, and this triangle, these two triangles ABD and BCD will turn out to be congruent to each other. Since this B is equal to this B, this A is equal to this, and the other side is common, so with SS rule the two triangles will be congruent. So angle A would be equal to angle C and not the other two angles B and D. Perimeter, sum of all the sides, so 2 times A and 2 times B, add them up. Area, similar to the area of rhombus, it is half into the product of diagonals that you have. Half into the product of the diagonals that I can use up. So if I have to compare all of them at a glance, I'll look at the properties such as, now in case of square, all the sides are equal, they are parallel, the vertex angles are 90 degree, the diagonals are equal, the diagonals bisect each other, the diagonals bisect each other at 90 degree, diagonals bisect the vertex angles, and everything is there in case of a square. So square is a perfect thing which satisfies all the things. If I compare square with the case of rectangle, now in case of rectangle, all the sides are not equal, only opposite sides are equal, and the diagonals do not bisect each other at 90 degree. The diagonals are not bisecting at 90 and the diagonals are not bisecting the vertex angles. If I compare the case of parallelogram, again I know that the vertex angles are not 90 but the opposite angles are equal and the adjacent angles sum up to 180 degree. Diagonals are also not equal but they bisect each other but not at 90 degree. And they do not bisect the vertex angle. So you can look at this chart and you can remove any confusion that you have. If you look at the case of rhombus, rhombus is similar to square, only difference between being vertex angles. There all angles, I mean to say I am talking about the vertex angles. Vertex angles are not 90 degree that you have in case of rhombus and the diagonals are not equal. So if I make the diagonals unequal and the vertex angle not equal to 90 degree, it's a case of rhombus that I have, which is very similar to the case of square, only difference being the vertex angles are not 90 degree and the diagonals are not equal. So you can look at this figure for 2 minutes and again understand the differences between each type of quadrilaterals that we have. Let's move ahead and look at the case of cyclic quadrilateral. Now what does cyclic quadrilateral means? A quadrilateral whose all the 4 vertices lie on the circumference of a circle would be known as cyclic quadrilateral. So if you look here, ABCD, all the 4 vertices ABCD lie on the circumference of a circle. Such a quadrilateral is known as a cyclic quadrilateral. This ABCD can be a square, can be rectangle, can be a case of rhombus that you have. So all the 4 points ABCD are known as concyclic point. That means they lie on the same circle. The property that will follow would be angle A plus angle C. Opposite angles of a cyclic quadrilateral are supplementary. I'm not saying they are equal because equal, it depends upon what type of quadrilateral it is, but what I know is opposite angles of any cyclic quadrilateral are supplementary. That is the thing that I know. And another property of cyclic quadrilateral is exterior angle is equal to the sum is equal to the opposite interior angle. So this exterior angle will be equal to opposite interior angle. Very simple to prove. I know angle A plus angle C is 180 degree. I also know angle C plus exterior angle C would also be 180 degree. So I can say exterior angle C would be equal to angle A. Exterior angle is equal to opposite interior angle. The most important theorem that you have in case of cyclic quadrilateral is Ptolemy's theorem. Now what is this theorem says? Sum of product of opposite sides. So what are we doing? Opposite sides AB and CD. Product. Opposite side BC and AD. Product. Sum them up. Sum of product of opposite side is equal to the product of their diagonals. So if you have the opposite side, I'll just name them as, let me call this as this is as A, this is what you have as B, this is what you have as C. Sorry, this will be A this will be D. So if you know A into C, which is the opposite side, plus B into D will be equal to the length of the diagonal AC into, will be equal to the product of the length of the diagonal AC and BD. To find out the area of a cyclic quadrilateral, I'll extend the Heron's theorem, and the formula that I get is S minus A into S minus B into S minus C into S minus D whole square root, where S is the semi-perimeter and is calculated as sum of all the sides divided by 2. The special case inside a cyclic quadrilateral is if a cyclic quadrilateral is a parallelogram. A parallelogram inside a circle will always be a case of a rectangle or square, because otherwise if it's a parallelogram, all the 4 vertices would not be on the circumference of a circle. The vertex angles have to be 90 degree for the parallelogram to exist inside a circle. Otherwise if you take this and if you try to make a parallelogram, तो ऐसा हो जाएगा, one vertex will be outside, one vertex will not on be circumference of the circle. So it has to be a case of rectangle or square with the diagonal of the square or rectangle equal to the diameter of the circle.